Hi, everyone. Welcome to quarter 4, week 4. Our topic this week is stars. I'm going to go through the notes briefly, introduce the reference table, and you'll have 2 assignments. One is a Google form based on the reference table. Another is a quote unquote quiz based on an article about the life cycle of stars. Here are the star life stages in your notes. Stars are born in gas and dust clouds called nebulae. These nebulae are scattered throughout most galaxies. So the material in this massive gas and dust cloud gets pulled together, pulled to the center under the influence of gravity. And this is where it begins to spin and really heats up in the center. The material in this protostar will eventually become a star. Some of the material may not end up as part of a star. It could become a planet, an asteroid, a comet. It may just remain as dust. So when the core of this protostar reaches a certain temperature, it becomes hot enough, the process of nuclear fusion begins and a star is born. When a star is born, this hydrogen gas fuses together to create helium gas. And this process of nuclear fusion creates lots and lots of energy. So the star glows, it contracts, and it becomes stable in this stage called the main sequence stage, which is where our sun is currently. Our sun is a main sequence star. It is in a stable life stage for approximately another 5 billion years. But eventually, our star and all stars will run out of their fuel and run out of their hydrogen. And the rule is the larger the star, the shorter its life, the faster it burns through its fuel. So when our star, our sun, or any star, starts to run out of its hydrogen, its core becomes unstable, starts to collapse, and the outer layers of the star expand and cool and glow red. It's predicted that our sun's outer layers will expand so much they will actually engulf or swallow the inner planets. Now, all stars evolve the same way up to this phase. The amount of mass in a star determines which path it's going to take from here. So big stars, unlike our sun, bigger stars than our sun, will eventually explode into a supernova, which could become a new solar system or a black hole. Smaller stars, more similar to our sun, or medium-sized stars, will eventually cool, shrink into what's called a white dwarf, and eventually all the light fades and they become what's called a black dwarf. This is the characteristics of stars reference table on page 15 of your reference table booklet. You need to use this to complete your Google form. Let's take a look at the x-axis. On the x-axis, we have the temperature of the stars. Note, the temperature gets hotter as you go left. This is unusual for a graph. Normally, values increase as you go to the right. So pay attention. The cooler stars are on the right, hotter stars are on the left. Notice temperature is determined, well, the color of a star is determined by its temperature. So cooler stars are more of a red-orange color. Medium temperature stars are more of a yellow-white. And the hottest stars are blue. So temperature is directly related to color. A star's temperature corresponds with its color. Let's take a look at the y-axis. Y-axis is called luminosity. It says it's the rate at which a star emits energy. You can just think of it as brightness. So if we take our sun, which is a star, and we assign that a value of 1, a luminosity of 1, if you were to put all the stars compared to the sun, this luminosity, this brightness, the amount of energy these stars are emitting are 10 times that of the sun, 100 times that of the sun, 1,000 times that of the sun. So all the stars on this table above the sun are brighter than the sun. All the stars underneath the sun in this table are dimmer than the sun. These are the names of the stars, this little circle with a plus sign in the middle of it. These are the names of other stars. Obviously, very few other stars compared to how many are out there. What directly corresponds with luminosity? It's directly related to luminosity is their size. So go over here. We have the massive stars. The biggest stars are near the top of the table. The smallest stars are near the bottom of the table. There's a direct relationship there. Okay, let's take a look at some examples of how you would use this table. Well, first of all, let's go back to this right here, this kind of like worm-like shape cluster of stars. These are the main sequence stars. So this is where our sun is. It's in the main sequence stage of life. Notice right here it says early stage. As stars age and grow old, remember, intermediate stage, they will swell into those red giants, okay? Bigger stars are called supergiants, and they are also in a later stage of life, the intermediate stage of life. Toward the end of life, the later stage, the dying stars are down here called white dwarfs. And notice their temperatures are still very, very hot. Although they are dimmer and smaller, their temperatures are still hot because they're on the left, closer to the left side of the table, but they are at the bottom left. So not as big, not as bright, but still very, very hot. And some of these bigger stars, like the giants, are over here on the right side of the table. So they are cooler, although they are still very big and very bright. Let's take a look at Betelgeuse, for example. Now, Betelgeuse is a very massive, very bright star, but also very cool. Betelgeuse, you can find it right away, is in the constellation Orion. Here it is, right here. Very big, very bright. You can see it with your naked eye. It's kind of orangish, reddish colored. This is a picture taken with a telescope, obviously magnified many times. You can see a lot more stars than you can see with the naked eye in the background. And there's some interesting phenomenon going on with Betelgeuse this winter. Scientists have observed that it is dimming. It's getting dimmer, which may be an indication of it, the end of its life, that it may end up as a supernova explosion. What are some other stars? Rigel is also in the constellation Orion, which unfortunately we cannot see tonight. It's in the it's a winter constellation. So Rigel, if you draw a straight line down from Rigel, is a blue-white star. It's also very massive and very bright. Rigel makes up the foot of Orion the Hunter. This is his belt, his shoulders. These are his feet. Ha ha. So this is Rigel, a blue-white, very massive, very bright star. Under Orion's belt is the Orion Nebula. So this is a star nursery where lots and lots of stars are born in the very early stages of life. Another star from your table, Aldebaran, is a giant star. It's in the group of giants. Aldebaran is also kind of an orange, cooler star. It's larger, more massive, and brighter than our sun because it's above it. Aldebaran is here. It's in the constellation Taurus, the bull. So this is supposed to be the bull's head. And these are the bull horns. So there's Aldebaran. It's kind of like the eye of the bull. Another star, Polaris, the North Star. Polaris is a yellowish, whitish star, bigger than our sun, brighter than our sun. Polaris is a really significant star because it is the North Star. Oh, I forgot Sirius. If you can find the Big Dipper, which is out all year round in the northern sky, here's the Big Dipper. It has 3 stars in a row. Here's the scooper, or the dipper part. Think of it like a big ladle to scoop out your soup or your sauce. And these last 2 stars in the Big Dipper are pointer stars. So they point to Polaris, to the North Star. So if you can find the Big Dipper in the northern sky, you can find the North Star. And the North Star, Polaris, this kind of whitish, yellowish star, is part of the Little Dipper, but the Little Dipper is very difficult to see with the naked eye. You would have to be somewhere really, really dark without any city light pollution. And obviously this one was seen with a telescope. Now, another winter constellation I forgot about is Canis Major, which is a dog. And this is supposed to be his snout, his eye, his body, his back legs. Sirius is his eye of the dog, Canis Major. Sirius is one of the brightest stars in the winter sky. Sirius is a white star, brighter than our sun. And that is the star that makes up the eye of Canis Major. And that's actually Orion's dog. So if you find Orion, the constellation Sirius is right over here, following Orion as he hunts. A rule about the Big Dipper. Here's the Big Dipper. Spring up, fall down. So right now we're in the spring. So if you go out tonight, 9, 10 p.m., the Big Dipper is actually going to be upside down in the sky. And you can find the scooper part, the pointer stars, and they point to the North Star Polaris. So in your assignment, find the key words in the question. So for example, if the keyword is giants, find the giants in the table, follow the giants down to find their temperature and color, follow the giants left to find their luminosity, or right for their size. If the key term is 6,000 Kelvin, then find the temperature, 6,000 Kelvin. And you know all the stars that have that temperature will be along that vertical line. Polaris, Alpha Centauri, and the sun. Say the key information is luminosity of 50,000. So it has 50,000 times the luminosity of our sun, somewhere along a line between 10,000 and 100,000, and that includes Spica. Say you're given a star, such as Polaris. So all you have to do is find Polaris in the chart, make a straight line down to the x-axis to find Polaris's temperature and color, make a horizontal line straight over to the y-axis to find Polaris's luminosity. If you're looking at different quadrants in the table, the upper right quadrant, if you go straight down, these stars in the upper right are cooler and red, orange in color. The stars in the upper right are very luminous and very massive. So these are the big yet cool stars. For example, if you're going to the bottom left of the table, these stars are very hot and blue-white in color, yet they are not very luminous, only a fraction of the luminosity of the sun, and they are not very big. So make sure you have your table open in a separate tab or the actual physical reference table booklet in front of you when responding to the questions in the Google form. Comment, email me with any questions. Get started early in the week so your questions will be answered by the due date. Okay, thanks for listening, everybody. Sorry so long.